Hello, I'm Robin. So today we will be discussing this question number 51 from the GATE Physics 2023 paper. Now, before I start the question, so we would like to introduce like what topic this question is about. So as you can see, it's the basically infinite two-dimensional square well. So this is basically from the normal well potential problems which are require solving the Schrödinger equation, the time independent. Okay. So you must have done one-dimensional infinite square well. So solving it in 2 days also very similar, and we can generalize the solution to that, and which we will be using to solve this problem. So let's start the question. So consider a particle in two-dimensional infinite square well potential of site L. Now your particle is confined in this infinite potential, which is constrained between x from 0 to L and y from 0 to L. So just to give you idea of how this potential would look, so in 2D, if you take this box which is of the size L, and if you draw your axis, so this is 0 and this is L, right? So now after this it is infinite, and here it is 0, right? So if you solve the Schrödinger equation in 2D, where V is 0 in this region, basically E psi, right? Because V is 0 in. Now the only difference is now this equation has both the x and y component. Now this can be by separation of variables. It can be reduced to two independent equations in x and y, and those would be nothing but just like 1D potential, infinite potential well. So your general solution would be psi of xy is nothing but 2 by L times sine nx pi x by L, 2 by L sine ny pi y by L. So which is basically 2 by L sine nx pi x by L sine ny pi y by L. Now your nx, ny goes from 1, 2, 3. So you are given in this question that your wave function in the state where these particle is, the wave function for that particle is 0 only along the line y equal to L by 2. So put y equal to L by 2. So okay. That means if this is 0, only for this y, then your ny has to be 2m. Okay, so the minimum, so let's say basically even number, but since we want only along y equal to L by 2, that means there should be only the solution should be like this. This is y equal to L by 2, and this is for ny equal to 2. But for ny equal to 4, there would be 4 nodes actually, right? That would be this, 3 nodes. So then this is not the one which we want. Okay, so which basically, and even for nx, we would just have the ground state, which is nx equal to 1. So considering all this, your nx equal to 1 and your ny equal to 2. And if you write the energy corresponding to this, that would be now that is given, it is E. So you put things 1 square plus 2 square, which is 5. So your pi square h square by 2ml square is E by 5. Now this is the key expression which is needed for this problem. Now the ground state. So E naught would be basically E1, 1. So that means 1 plus 1, 2 pi square h square by 2 ml square. Now this quantity is E by 5. So this gives 2E by 5 as the answer, which is option B. So that was a very simple problem and revised the concept of the infinite square well. So the answer is B. Thank you.